Welcome to What's New with GeoInterface, Traits for Interoperability. I'm Maarten Pronk, and this is Rafael Schouten. Or Schouten, oh, I should say. Here we're in Holland, so it's Schouten. Okay, so why GeoInterface, right? So you go back to the question of, very simple, what is a point? Everyone likes to define points in their packages. So a point would be a vector of a few floats. It could be a tuple of a few floats. It could be a tuple with also, let's say, a third dimension, which probably would be the height. Some people don't like vectors because they're too slow and implement static arrays. Then people like some more explicit stuff, and they make a name tuple with an x and a y, or maybe some other names. If you reverse the tuple, then you have a different type, and again, it's something different. And then you can also implement structs, and well, basically, you can go pretty nuts already with just defining a point in your ecosystem, in your package. And if you move on to LineStrings and Polygons and other complex geometries, it becomes even harder to define really what a point is. So hence, a long time ago, I think Martijn Visser, I just saw him here, and Yeezian made a GeoInterface package to basically standardize what is geometry in the Julia ecosystem. And this is based on the simple feature standard, and we talked before about this all the way back in 2019, 20, and 22 at JuliaCon, I believe. And that previous GeoInterface was basically based on supertypes. So people were expected to, if you implement GeoInterface to standardize geometries, you implement from an abstract point or abstract multipolygon. And of course, that only works if you can actually subtype. If you're already subtyping abstract array, you cannot implement this spec. And so we came to a 1.0 design, and for that I will hand over to Rafael.
So at that point, there are a lot of geometry packages in the ecosystem, like Geometry Basics, that already subtyped array and had that we couldn't get to subtype our type, GeoInterface type. So the idea was to rewrite the package with a traits-based system. And there are a bunch of attempts at this. I think there was about 2 years of this rewrite. Actually, Maarten Visser, I think, started that. Did you? Yeezian started it. But it was over a long time, and finally we finished it a year and a half ago. And the idea of using traits, like the reason for using traits is that packages can implement the interface without inheritance changes. So Geometry Basics can implement the interface and does, and a lot of other packages. So we don't have to argue about who has the dominant type or force any changes in the ecosystem. Geometries can be abstract arrays if they want. And a really good side effect is we get no copy interop for free. So in R and Python, it's a really big deal to get no copy interop, and they use arrow and things, where we get that for free because of the traits interface and packages reading all types. Okay, so what the interface looks like now is this set of methods that you need to implement. So here for this custom point, we have to implement isGeometry on the type. Is this kind of thing a geometry? We have to give it a trait. This thing is a point, so we have a point trait. And then we need to define methods like the number of coordinates in the point, getting one of the coordinates out by index, and a bunch of other methods. It's quite a complicated interface, actually. We have the same kind of thing for polygons, same start, but here we define ngeom and getGeom, so we're getting the geometries out of a polygon. And those will be line strings or linear rings, which will again have to implement this interface. So we have this nested getters. We have other methods like GeoInterface.crs, GeoInterface.extent, that will get CRS data and extent data if it exists in the object. Of course, not all geometry types implement these. They're really geospatial things. We have a bunch of other methods like area that kind of not working so well, but we'll talk about that later. Currently, we have 41 implementations of this interface, so it's pretty widely used now. There's common sources, Geometry Basics, ArchGDAL, LibGEOS, Shapefile, GeoJSON, WellKnownGeometry, and KML. And there's a bunch of consumers. We can't fit them all on the screen. So that's about 30 packages that will consume all of these geometry types. And none of the consumers need to depend on the sources, is the idea. They don't know anything about the source geometry types, but they will accept them. And then we have 850 indirect. Mostly that's through Geometry Basics and other geometry packages. Not people directly using GeoInterface. So things that work great at the moment is this object accessor interface really works. So GeoInterface can convert between most ecosystem geometries. This single, you can just convert to ArchGDAL, convert to Geometry Basics. Consumer packages like GeometryOps and Rasters accept most geometries, so you can rasterize LibGEOS or a shapefile and that will just work. You can use them in GeometryOps methods. And packages like GeoJSON, GeoDataframes, and Shapefile will write any kind of geometry. So you can just call, you can see here we have a really simple geometry, just a point in a data frame, and the same command, GeoJSON.write, GeoDataframes.write, Shapefile.write, will write a file from any kind of geometry. There are still things that could be better, of course. The predicates and functions don't really work at the moment. We don't have a way of dispatching on a lot of the types, and we haven't decided what kind of blessed standard package to use. We're very hesitant to go down a plots or Mackie like style of interface where you have a default backend and a loading method. So some of those methods don't work that well. Yeah, plotting kind of works, but there are a few things like we have to use, like using GeoInterface Mackie to get plots of some geometry types to work. The documentation and discoverability is really bad, and that's the thing about having this ecosystem-wide interface, is that it's hard for people to know what is doing, where are things happening, what package do I make an issue to, what documentation do I read. So we need some integrated docs. And there are a bunch of plotting and conversion things that aren't fully implemented for features and feature collections. Okay, so our future plans are implementing CRS traits. We're really keen to have projected in geographic traits, so coordinates in meters and coordinates in latitude and longitude. If you do something like area or length on those objects, it will be done correctly, spatially, instead of always being done in meters, which is kind of the default. And it happens in Python and other ecosystems a bit as well, but we're pretty bad at that. We want to implement raster traits, so we know when an object is a raster and it should have extent and CRS traits. These are all open pull requests. And this having default implementation backends work, and we've got a bunch of design issues to resolve there. Ansha wanted me to plug this Julia Geo tutorials, and hopefully this is going to turn into some kind of across the ecosystem documentation that will start to pull these GeoInterface things together. Yeah, that's it. Thanks a lot. And any questions?
Thank you. We have time for, first of all, applause. Yeah. We have time for one question. Anyone in the back of the room, maybe? No.